Inspired by the half-human, half-horse beings of ancient Greek mythology, the field of astronomy features its own version of Centaurs, distant celestial objects that orbit the Sun between Jupiter and Neptune. NASA's James Webb Space Telescope has recently mapped the gases emitted by one of these objects, revealing a diverse composition and offering new insights into the solar system's formation and evolution. Centaurs are former trans-Neptunian objects that have been drawn closer to the Sun by subtle gravitational interactions with the planets over the past few million years and may eventually evolve into short-period comets. They are considered hybrid because they represent a transitional phase in their orbital evolution, sharing characteristics with both trans-Neptunian objects from the cold Kuiper belt and short-period comets that have undergone significant changes due to repeated close encounters with the Sun. As these small icy bodies are in a transitional phase of their orbits, they have become the focus of numerous studies aimed at understanding their composition, the causes of their outgassing, the release of ices from beneath their surfaces, and their role as a connection between primordial icy bodies in the outer solar system and evolved comets. Recently, a team of scientists utilized Webb's NIR-SPEC, or Near-Infrared Spectrograph instrument, to gather data on Centaur 29P1. This centaur is known for its highly active and quasi-periodic outbursts that occur every 6 to 8 weeks, making it one of the most dynamic objects in the outer solar system. They discovered a new jet of carbon monoxide, or CO, and previously undetected jets of carbon dioxide, or CO2. These findings provide new insights into the nature of the Centaur's nucleus. Centaurs can be seen as remnants from the formation of our planetary system. Their extremely cold temperatures allow them to preserve information about volatiles from the early solar system, explained Sarah Faggi from NASA's Goddard Space Flight Center in Greenbelt, Maryland, and American University in Washington, D.C., the lead author of the study. Webb has truly opened the door to an impressive level of resolution and sensitivity. When we first saw the data, we were thrilled. We had never encountered anything like this before. The distant orbits and resulting faintness of Centaurs have made detailed observations challenging in the past. Previous radio wavelength data on Centaur 29P indicated a jet directed toward the Sun and Earth composed of carbon monoxide. The Webb telescope was able to detect this face-on jet, and due to its large mirror and infrared capabilities, it also conducted a sensitive search for various other compounds, including water and carbon dioxide. The absence of water vapor in 29P's atmosphere may be linked to its extremely cold temperatures. Webb's unique imaging and spectral data uncovered new features never seen before: two jets of carbon dioxide emerging in the northern and southern directions, along with another carbon monoxide jet directed northward. This marked the first definitive detection of carbon dioxide in Centaur 29P. Using the data collected by Webb, the team developed a three-dimensional model of the jets to analyze their orientation and origin. Their modeling revealed that the jets originated from different regions of the Centaur's nucleus, even though Webb is unable to resolve the nucleus itself. The angles of the jets imply that the nucleus could be an aggregate of distinct objects with varying compositions, though other possibilities remain plausible and cannot yet be ruled out. The dramatic differences in carbon monoxide and carbon dioxide abundance across Centaur 29P's surface suggest it may be composed of multiple pieces, said Geronimo Villanueva, co-author of the study at NASA Goddard. It's possible that two bodies merged to form this centaur, resulting in a mix of very different components that followed separate formation pathways. This challenges our understanding of how primordial objects are created and stored in the Kuiper belt. The reasons behind Centaur 29P's brightness bursts and the mechanisms driving its outgassing through the carbon monoxide and carbon dioxide jets remain significant areas for further study. In comets, it is known that jets are often driven by the outgassing of water. However, due to the Centaur's colder environments, water ice cannot sublimate, indicating that their outgassing behavior is distinct from that of comets. "We only had time to observe this object once, like a snapshot," said Adam Mackay, a co-author of the study at Appalachian State University in Boone, North Carolina. "I'd like to revisit Centaur 29P over a longer period. Do the jets maintain their orientation? Is there another carbon monoxide jet that activates at a different point in the rotation?" Studying these jets over time would provide deeper insights into what drives these outbursts. The team is optimistic that by enhancing their understanding of Centaur 29P, they can apply similar techniques to other Centaurs. By broadening the astronomical community's knowledge of these objects, we can simultaneously improve our understanding of the formation and evolution of our solar system. These findings have been published in. The observations were conducted as part of General Observer Program 2416. The James Webb Space Telescope is the leading space science observatory in the world. Webb is unraveling mysteries within our solar system, exploring distant worlds around other stars, and investigating the origins and structures of our universe.